All right, this video is us helping maybe catch some students up from class, so maybe a little faster, but we were walking students through how to approach and think about this wheel for our CO2 dragsters from Pitsco. It was the PX Pitsco wheel. You can look it up on the website and get a view, but we want to we're not going to design the wheel. We've purchased them. This is what they are, but we'd like to put it in our CAD model. And so we need to just kind of visually inspect it, try to understand the overall shape and form. And it's not going to be perfect what we're going to do, but we're going to have a pretty close mock-up of it. It'll be decent, okay? So obviously this has, kind of a round symmetry. It's a turned round piece, and it's looks like a wheel. So when we talk about a wheel, let's break it down a little bit. Normally you look at a car and we might kind of say the wheels in the car, but we've got the outer part is the tire, the rubber, and that goes onto a piece that would be a wheel. Right now, this is not rubber. This is all one solid piece, I'm sure made with plastic injection molding. So plastic is injected into a mold. When it's liquid, it cools and hardens, and then out pops this. But it looks like they're trying to illustrate through their Onshape that there's maybe a tire section. There's, I think, a little break, a little visually, I can see kind of a little thing that might acknowledge the idea of a wheel. And then that wheel doesn't have a face right here on the outside. I'm going to call this the outside, and this side the inside. So there's not a face to the wheel right here. There is one inset. Okay, and that face, I'm going to kind of ignore the detail of all these little circles, but think of there's a face or a plane that's down inside there that would just be kind of a flat disc inside there if it weren't for that they had drilled out all those little holes. In the center, there's some plastic here that bumps out. Maybe we'll call that the hub. So kind of at the center of the wheel. And flipping it over and looking on the back side, all right, we can see kind of the back side of this wheel and that face that had the circles cut out. And then kind of opposite the hub, we see this piece that extends, and that's going to be for the axle of the car to stick in. So just a cylindrical metal axle will just kind of press fit right into that hole. Looking from this side, this piece extends beyond the width of the tire. Okay, the wheel piece that's in there, I don't know if you can tell this with a ruler as well, but if I put a straight edge against it, it'd be easier for you to see yourself or to really kind of zoom in. The ruler is not making contact with the back side of that wheel. I'm trying to hold this in just ever so slightly. Hopefully you can see that there's a gap there. That's almost kind of right there, just rocking right there for you to see it. So I'm pointing that out because these are some of the details that I want to observe and notice to be able to start sketching the general profile that I think would help me to create this shape. Okay, I'm going to create it through a revolve. And so let's give, just on some graph paper here, I'm going to make a line. Let's dash, and this is going to represent my center line. Okay, and I'm going to think about what shape would it take to revolve and make this. Now, if I just make a rectangle, okay, as a sketch and revolve that, I'm going to get just a solid cylinder. It'll be a solid disc, and that's not what this is. This is hollow here from the outside of the face. This is, there's a big cavity or recess here. From the opposite side, we don't see, because it's not a real tire, we don't see a sidewall to this tire. It's just all open back there. So thinking about what I've got the tire here, I can see the outside of the tire and I can see the inside of the tire, and it's open from this side. So trying to modify this idea a little bit, think about having the outside of the tire and then the inside of the tire, okay, like that. And then that's going to come over until it meets this outer wall. And then that outer wall, looking at it up close, this doesn't look flat to me. I don't know if you can tell from a video, but this actually has, it appears to be a little bit of an arc. So I'm going to try to acknowledge that. I'll acknowledge it maybe more than it is in real life, but I'm going to put kind of an arc that bows out just to say it looks like a tire that maybe is inflated and bulges out from the air pressure. That's what it looks like. It's subtly that this would be an arc, not a line segment. And then, okay. And then from there, I acknowledged before, it looks like there's, they tried to mold and acknowledge a wheel relative to the tire. So I believe I'm seeing a little bit of a flat spot. Okay. And then it turns in this way. Okay. Now, let's say that the edge, this inside edge of the tire is kind of a cautionary line. I'll just use this yellow highlighter as caution. Remember I said it didn't appear that the back side of that wheel piece went as far or was in plane with the edge of the tire. So as I draw this, I'm not going to go all the way to that line. I'm going to stop short a little bit, and then I'm ignoring all this detail on the inside. Imagine that the little protrusions of the hub were not there. Imagine those holes were not there, and that it was just inside, just a flat bottom. Okay, so for right now, I could draw this just straight down like that. Okay, and then this has thickness. There's thickness to that face, that wheel. There's this outside face and an inside face, and there's got to be some thickness, and there's got to be some thickness to the tire and some thickness to the tire or to the wheel or the outer edge of the tire, like the tire tread. Sorry, and so I could kind of trace an offset, if you will, kind of around all of that, something like that. And if I'd revolve that, I think I'd get something that starts to look like a wheel. Now we're going to capture a little more detail. I have this piece that extends off the inside of that face, and ignore that there's a hole in it. Maybe I'll add the hole later, but this extends, and if I hold it in this orientation, you can see that it extends beyond the edge, the inside edge of the tire. And so from that face, I've got a piece that sticks out, all right, again, past that caution line. It goes quite a bit past, and it's going to go to the center line, my outside view of it. And so I could add this to my sketch. And if I want to add just a teeny bit more detail to my original, even my first sketch, then I might start to look at the inside here and acknowledge that that face on the inside is not going to be flat, but there's actually a couple circles, a couple cylindrical forms that I see. There's one that is larger, that doesn't stick out as far as then the interior one that's smaller but sticks out even further, right? So thinking about that from the side view, I could have a rectangle, kind of notch out a rectangle here back to the center line because it's solid. There's no hole, so I'm going to go all the way to the center line. And then I can make a smaller step down, a smaller rectangle next to it. And then if I were to revolve this profile, I'm going to kind of put all this together now. That would create material mass that looks like this wheel. Okay, so there's step one, is just a visual inspection and trying to break this down into what shapes you see, okay, and what lines. And now, if you had the ability, you could maybe get even better understanding if you're willing to destroy one and have a safe way to cut it in half. So here I took one of these wheels and actually cut it in half on the bandsaw, and I get more detail and more understanding of the part than I would have had. And so this actually reveals some things to me that suggest mine's not perfect, and that's okay. I'm going to stick with mine. This is not supposed to be a perfect reverse engineering of this wheel, but we're just trying to get close. Okay, it's going to be a close mock-up to start. Okay, so the next step is going to be to go over to Onshape, or whichever CAD program you might be using. And let's see here. I'm going to start a new sketch on a plane, and just a little suggestion for you is if you have other things in your Part Studio, so for Onshape users where you model multiple things inside a Part Studio, I would suggest that maybe you don't sketch off to the side or vertically, kind of think of these as lanes, to a part that you already have in your part studio. Okay, if I went to model this bushing and I did it directly to the side of the washer, then Onshape starts to want to create some horizontal or vertical constraints back to this other piece. If I were to start modeling this wheel to the side or below the bushing, same thing. It keeps trying to create constraints with endpoints or points of this with points over here. And I don't want to create any sort of relationship between the two. So I would avoid being to the side or above or below. That's just a friendly tip. Okay. So the next thing I'm going to tell you is know what unit you're working in your program and what scale. Have a sense of the scale when you start making your very first reference line. Even if you don't put a dimension to it yet, usually the CAD program is going to let you see the distance of your first line segment. So in Onshape, we can go to the document menu and check workspace units and know if we are working in millimeters or we're working in inches, okay, and be mindful of that. So, all right, so I am in inches, which matches my dial caliper. The very first line I'm going to make is a construction line. And again, I'm kind of giving myself some distance down from, I'm going to leave that wheel already modeled, but I'm going to make a line segment that's horizontal that represents that center line. Okay, now keeping that, let me get back to my camera. Keeping this in mind here. So this is my center line. You know, holding this thing, you can just approximate right now about how big this is, right? It's not that big of a thing, but it's also teeny tiny. Maybe this is like an inch, you know, the width of it. So in terms of making a line that's going to represent that, starting to give myself some sort of perspective in my sketch, I think I only need about an inch or so. I don't need 100 inches, or I also don't need 0.05 inches. So I'm just paying attention to the number on the screen there as I make this, and I make it, you know, close-ish to the scale. So again, it didn't have to be really dimensioned, but I've got a little bit of perspective. And then to aid in this perspective, I'm thinking that what I'm going to do is provide the first segment of my sketch is going to be this top segment, I think. Make a segment here and get a distance that represents this. It'll be a radius, but for me, I'm going to measure diameter. So this furthest distance from my center line. Okay, so I'm going to go ahead and measure this. Make sure your caliper is reading 0 when it's closed. Also remember to always use your thumb wheel to operate the caliper. That's the best practice of it. So we're going to go and take a measurement of the outer diameter. Now, I'm not going to take the time in this video to be like uber precise, but just to get some quick rough numbers. So I'm about 1.560. Okay, now that was a diameter. And on this, I need to remember that what I have is going to be a radius. So I need to cut those in half. Anything that, right, is only from the center line out is really a radius. So I'm going to make my first line segment represent the furthest line segment of my profile. So I'm just making a line segment. I'm going to switch to the dimension tool right away, and I'm going to get this distance right here to be 1.560, which is what I just said, and then but I'm going to divide it by 2. Okay, and that way I know what zoom level I'm working on. Sometimes people, their original lines and they're starting to draw a profile is way, way zoomed in or way, way zoomed out. So now I've got some scale. Okay, from here, so I've got a line segment. I know I don't have any dimensions yet, really. Like I didn't dimension length that. I guess I got that distance. But I'm going to start working my way around this shape and just kind of mock out this profile. So I'm going to come right here with a little arc. So it's going to be back and forth. So I'm going to use my 3-point arc. I'm going to come down a little bit. I'm okay getting a vertical constraint between the endpoints of the arc. I'm going to let that bow out to the right as my outside of the wheel just a little bit. Then I'll switch back to my line segment and go straight down just a hair. Remember, that was what we observed. We thought that looked like there's a little flat spot to acknowledge a wheel. Okay, then I'm going to turn in, and I'm doing this all just to the eyeball. So, you know, trying to make it look somewhat proportional to what I'm seeing. Okay. Now be careful you don't click or align things where Onshape or your CAD program wants to create constraints like this, like these 2 points being vertical. You may think, what is that point? That's the center of the arc I made. So I don't want to create a relation that I did not intend. So I'm going to back away from that. I do want to be, I know, to the right side of this point, right? We knew that that interface of the wheel did not stick out or go all the way back to the edge of the tire. So I'm going to put that right there. And then I'm thinking that I'm going to skip this detail, this little step down for the sake of this video right now, and that we're just going to come straight down. Well, we can add that in later to right there. So that's all the way to the center line. And then I'll come all the way over. And at that point, I'm going across that cautionary line, past where the edge of the tire is. And that's representing kind of how far out the tab that the axle will go into extrudes. So I'm going to go straight down to the center line. Now I'm going to come out past that mark, right? And then from there, think about it, this is really like just tracing back across this path with an offset. So I'm going to make a little turn vertical, and then I'm coming back this way, and I'm just really kind of hugging everything. So I'm going to come up just a little bit. Again, I will come back and add dimensions later. Do not click right there. Again, I'm being mindful that I don't get any constraints that I don't intend to, like that one. Okay, so you just got to move your mouse a little higher, a little lower, generally to not get a constraint. From right here on the inside, this depends on, how detailed you really want to be, but it appears that in real life, maybe that's a curve, just like on the outside to match the curve of the inside. And remember, I'm not trying to be perfect here. I'm just trying to be quick. So I think I'm going to just stick with a line segment and then come back over. In this case, at the end, I do want to get a vertical constraint. So again, it's not going to be perfect. It's going to be close. So from right here, I'm going to go ahead and accept the sketch before I do more work, because that creates a restore point for my work in Onshape. So I'm going to accept it. I'm going to make sure it's saved that. And I can go right back into the sketch by double clicking. But what might be more fun is to go ahead and revolve it and just see what it looks like from right here. So if I turn on revolve and choose that profile, and then choose the revolve axis and accept that, I can take a peek. Okay, so it may not look perfectly proportional. Kind of the ratio of some of the different dimensions you see may not be a match to real life, but you see the form, and that's what we want. So it looks like the tire on the wheel, and the wheel's inset, recessed down to that face. That face is going to have some other detail, and on the back side we have that face. We have a little tab coming out that'll need a hole put in. So, and it's hollow otherwise inside that cavity. So it's looking like our part. So I'm going to go back into this, and we're going to begin to add some dimensions. I went to the revolve instead of the sketch. That will get it to be closer. Okay. Now, mine's not perfect by any means, but I'm going to exaggerate this to be where I definitely know it was not a good representation in terms of the scale, the proportion. Okay. So by bringing just kind of bringing this inner diameter or inner radius here of the wheel in much closer to the center line. Let me go ahead and accept it, and you'll see like, oh yeah, that wheel looks way too small, right? The reason why I do that is because I want to intentionally have something happen when I start placing dimensions that you might deal with at times, and you'll see how I handle it. So let's say I want to start with some baseline dimension where I dimension from the center line out to all these horizontal lines, that one, that one, that one, that one. And I don't need that one because that one's already got it. But I get all these distances, which are really, on this sheet, radiuses. In real life, it'll be easier for me to measure a diameter all the way across. So on the outside of the wheel first, okay, I'll stay on that side. I can measure this inner diameter right here by putting this side of my caliper on the inside, and those machine faces will face out. I'm going to measure right at the outer edge as opposed to sticking it in, because that piece is actually not those faces are not perfectly parallel outside. It's one of the things I know that is not as accurate, is where we're kind of pretending this is a little more squared up than it really is. But I'm going to get on this outside face. What is this diameter? So instead of just making contact and being done, I'm going to give it a little bit of a gentle turn, a little bit of an outward pressure, and just to make sure I'm getting a diameter, not a chord, and see what I'm getting. I'm getting about 0.745. Good enough. So I'm going to dimension, use pencil, dimensioning this right here. But that was 0.745 is what I read, but I've got to remember to cut that by 2. So I can zoom in for my camera for you. I got to write really small, but so here's what I was trying to show you. When I place this dimension right here, and I'm going to type that value, 0.745 divided by 2, watch where that line goes. I had it way too close to the center line, so it moved to the correct distance. The issue is that the other stuff around it didn't move, and that's okay. So what do? Well, stay calm, turn your dimension tool off, and manually move your other geometry around so that things are back on the correct side contextually from what you intended. So if we start placing dimensions when these lines are not on the right sides of each other, that's going to really make things kind of get locked in an incorrect manner. So I'm going to just manually grab that line and drag it and get it to the correct side. Okay, another thing is that on this outside of that, I had this little flat piece, and that went towards the outside, not towards the inside, right? So I'm going to grab this endpoint, I'm going to drag it and bring it to the opposite side. So when that line moved, it didn't take things with it. Okay, so that's okay. You just turn off the dimension tool, manually drag things and get them positioned relative to each other on the sides that you want, and then you can go back and place another dimension. So let's see, I've got that one already. So on the outside, I've kind of got my main 2 dimensions. Let's start on the inside of the wheel. So on the other side, if I flip the wheel around in real life, and let's go from the center line to this piece right here. Okay, so I'm flipping the wheel around, and now I'm looking at diameters that I can get. So the first one I get is this piece right here. So I'm going to get that diameter. So I'm going to take a quick reading, and I'm about 1/4 inch. It's about 0.250. Again, I'm being pretty quick, and this is a rough, so I'm not going to take the time to be as perfect. So about 0.250, but divide that by 2, should be about 0.125, right? My computer's being slow or something. It's processing. There you go. Okay, so there's that. And then the next one I see from this side would be this outer diameter of the wheel. We got the inner diameter from this side, but there's thickness to that plastic, and so on this side we're going to get the outer diameter. And again, I know that it's not perfectly cylindrical, that thing's got an angle, but we're just going to grab that on its side. It's going to be close. And so what am I reading there? I'm reading about 0.774. So I'm going to dimension from the center line to here. I said 0.774. We're going to divide that by 2. And then the last one is going to be this inner diameter that we can see from the backside. This inner diameter of, say, the tire. So I'm flipping this around again, right? I'm looking at this where the tire is, and I'm going inside. I could try to measure the thickness of the tire and use that as well, but I'm just going to do this for the sake of the drawing I've got. The sketch I'm going. So I'm going to kind of make sure I'm getting a diameter, not a chord. So it's a little bit of rotation and a little bit of soft pressure pushing out, very subtle. But I've got 1.442. Again, I'm being quick, I know. So 1.442, divide that by 2. And there you go. Look, everything kind of stayed on the right side. And I'm going to accept that. That'll create a restore point and take a peek at it. And this should look more proportional to what I have. Okay, may not be perfect, right? So I only dimension things that were from the center line out. I have not done dimensions that are right and left, and that's going to be part 2. But this is where we got to for today. Was sketching, planning, and getting everything, all of those radiuses set up, okay? So I think distance from center line, we should be pretty good. But, how deep is this cavity? How long is this piece, right? So it's okay that it may not look perfect yet because I don't have dimensions on everything yet, right? All right, so there is part one of your PX Pitsco wheel.